Hi everyone, I welcome you all to the fifth lecture of this series. So today I will be continuing the last lecture that we have discussed on fluid statics. So what we told you about in yesterday, just briefly going through that. So fluid statics, I told you that it is the study of fluid at rest, and we have discussed pressure and how pressure is acting on the fluid parcel when the fluid is at rest. And we have seen the variation of pressure in the vertical and the horizontal directions. And I have given one question. So let's discuss the solution of that question first. So as I already discussed that for all the three vessels, the height is same. So because the height is same and we have discussed that the pressure at the base is only dependent on the height. So the correct option for this question is PA is equals to PB is equals to PC. So in order to explain this, that why pressure is only dependent upon the height, I will be taking example. Let's say I will be taking two vessels, but in both the cases, the base, the water filled is at same height. So let's say I am assuming that it is completely filled with water, let's say, and it is also filled with water. So the pressure at the base, if we want to find, let's say P1 is base and it is P2. So according to me, the correct answer is P1 is rho gh and P2 is also rho gh. And if atmospheric pressure is there, let's say some P naught, so then it is plus P naught. Okay. So now the question is P1 is okay, that you can see directly, but how for P for this case? So in order to derive that P2 is also coming to be same as P1, we are considering a fluid parcel, cylindrical fluid parcel, let's say three fluid parcel, something like this, and we will be going to check the variation of pressure in that. And another fluid parcel. So I'm taking three fluid parcels that are of cylindrical shape. So I'm taking, like, if it is like say H1, height of this fluid parcel and height of this fluid parcel is H2, then net H is H1 plus H2. That is my assumption. So this is 2, this is first, and this is third one, that is horizontal. So we will going to simply see how the pressure is varying along these fluid parcels. So let's take first parcel, and as you know at this bottom, mm, better to zoom it out. Let's call this point is A, this point is B, and this point is C. That is second fluid parcel, that is A. That is another fluid parcel, that is V, and that is third fluid parcel, that is C. So PA, so we need to find out the pressure at PA. So PA is P naught plus rho GH2. PC is PB, so it is PB plus rho G H1. And for the horizontal case, so this is PA into A same is equals to PB into A. So PA is equals to PB. So PC comes out to be PA plus rho G H1. So PC, that is also P2, is equals to P naught plus rho G H2. P2 is P naught plus rho G H2, that is coming from here. So we are substituting this here only. And what we get is P naught plus rho g H2 plus rho g H1. And so finally what we get is P naught plus rho g H1 plus H2. Okay. So the pressure at point 2 is derived as P2, that is P naught plus rho g H. So from here we have seen that from here we have seen that the pressure is independent on the shape of the vessel. It only depends upon the height and density of the fluid in fluid statics. It is not a very universal case. It is not a universal. But for fluid statics, when we are looking at these types of problems, this is the case. Okay. So this is about this. Let's see some more questions related to this. So let's say we have a question that is we are having three vessels having equal base area filled with equal volume of same fluid. Three vessels are as shown below. So let's say the three vessels are like this. So it is A, it is B, it is C. Given that A, AB, A is equals to AB is equals to AC. Options are PA greater than PB greater than PC. PA greater than PB less than PC. PA, PB, PC and none of the above. So in this question, what are you have to interpret yourself what is the height of the fluid in all of the three vessels, but all have same volume. All of them have same volume. So take 1 minute and I will discuss the solution to this. Okay. So volume is same for all. So VA is equals to VB is equals to VC. Means to say that AA H, we need to find H. A is equals to AB into HB equals to AC into HC. Basically, I am so first I am explaining what I am doing and then we'll tell you whether it's what I am doing is right or wrong. So if I do this, then height and area of volume A. So if you wanted to find this height and this area A, then according to what I am currently doing is HA is equals to HB is equals to SC, which gives me PA is equals to PB is equals to PC. But this is not a correct way of doing. So the correct way of doing this is because why this is not a correct way of doing? Because if you see, you cannot interpret this way whether the height is which height is what because you don't know the if you are taking AA into HA. So you are just taking A into HA. What about this? If you are taking B, so you are taking this area into this. So that is only correct for this volume is only correct for this vessel. So that will give you AB into HB. But if you take this, there is again some, if it is HC, so it is the HC should be like this. So SC should be like this. So A into SC will give you this area, this complete area. So what about this? This is removed from this. So this extra area is coming here. Sorry, this extra volume is coming here. This extra volume we are not taking. But in this case, it is correct. So this way, this is not the correct way of doing this question. We can do this question just by simply thinking about it. So let's think about it. So I will be removing that view part and make this a original list. Because you know the base area is same. Area is same. So just if you think, so as we go in this direction perpendicular to this here in this direction, so area is increasing. As the area is increasing, so it is definite that the HA will be lesser compared to the other two because in this case area is constant. In this case area is decreasing. So if you see the HA, first thing is very clear. HA should be less than HB and SC. Now compare B and C. So in case of C, as we move along this in this direction, you see area or covered by this is decreasing, which means to say that H should be higher in order to have same volume in the vessel. So HC should be greater than HB. Okay. So this gives me that HA, HB and SC are in the same way PA, PB, PC. So the correct option to this is this. Okay. Let's take another question. So now we have equal mass of, so the question is equal mass of three liquids A, B, C are poured in three similar vessels. If rho A is greater than rho B, greater than rho C, Then choose the correct option. Correct options are PA is equals to PB is equals to PC, PA, PB, PC, PA, PB is equals to PC, PB is equals to PC greater than P. Now, the type of vessel is not given. You need to interpret yourself, and whatever the vessel you may want to take, you can take. So I will be giving you 1 minute to think about it and then answer it. Okay, so it's a simple question. So for my simplicity, if I have to take the vessel and consider this question, then I will be going to take a simple mug type vessel, simple vessel. So row A, row B, row C, A, B, C. We know that P A is nothing but if you are considering atmospheric pressure is P naught plus rho A G H. We have given that it is all of them having a equal masses. So what is MA? So we are given with MA is equals to MB is equals to MC. So MA is nothing but rho A into volume of vessel A. MB is rho E, B into volume of vessel B. MC is rho C into volume of vessel C. Okay. So we have equal masses. It means to say that MA is rho A into VA and rho A into VA is nothing but rho A into HA into rho H into area. So base area should be same because all of them are similar vessels. So AA is equals to AB is equals to AC. So rho A. So let's put this here. So what we get is PA is P naught plus rho A HA into A and rho A into rho GH. So it is rho GH. So can we substitute rho in terms of mass? So that is P naught plus rho A into H is MA into G. By A. Similarly, PB is P naught plus MBG by A and PEC is P naught plus MCG by A. So now we know that MA is equals to MB is equals to MC. I am taking A is equals to AB is equals to AC to be capital A. And so what we get is PA is equals to PB is equals to PC. That's a very nice question. So the correct option is this. Okay. So next question is So that's a bit subjective question. That kind of question may be asked in board. A glass of water, 1 liter, has height 10 centimeter, base area 20 centimeter square, and top area is 50 centimeter square. The density of water is 3 kg per meter cube, and 1 ATM is given as 0.01 into 10 to the power 5 Newton per meter square. We need to calculate force acting on the base of the vessel due to fluid, and force another is force exerted by the vessel on the fluid as a reaction. Okay. So just for your simplicity, it is not giving, but because we have given base area is 20 centimeters square, I will make the diagram. The base area is 20 centimeters square. Sorry. Top area is 50 centimeters square. It is higher than this. And it is like this. This is 50 centimeters square. This is 20 centimeters square. And we need to find, and this height is 10 centimeters. Everything is in centimeter. We will solve and convert centimeter to meter and then as well. So let's do it. And then I will solve it in 1 minute maybe. First part is very simple. Let's solve this. So first part is we need to find force on this, force on the base. The base is pressure on the base into area of base. So pressure on the base is nothing but rho GH plus P naught into AB. P naught is given. So P naught plus rho GH into AB. So rho is 10 to the power 3 kg per meter cube into 10 into height is 10 centimeter, 10 divided by 100 plus P naught is 1.01 into 10 to the power 5. Area of base is 20 centimeters square. 20 into 10 to the power minus 4. So it comes out to be 101,102 into 10 to the power 5 into 10 to the power 3 into 20 into 10 to the minus 4. So 204 Newton. Please check the calculation maybe. I think it's correct only. Rho GH plus P naught, that is this. Okay. Second part is a bit tricky. So we need to calculate a force on the fluid. So for that, we need to make a free body diagram of this complete fluid, a parcel. So it's like, uh, so fluid, because it is at static, so fluid must take a shape of this. So mg is acting this side. So this base is pushing to this with PA. This is PA2. If I call it this is A1, then this is P naught into A1. So from this side it is acting like this. And rho GH is also acting in the same direction. So from the free body diagram, what we get is, and this is the force that is acting on the fluid, let's say F. So F plus rho GH is equals to P naught into A1. Sorry, P naught A1 plus mg. Rho GH is in the same direction. Rho GH A is the base area is equals to F plus P naught. So this pressure PB into AB. So calculate this. On calculating this, we will get F. So F comes out to be P naught A1 plus rho GH into A2 minus AB into AB. So P naught is 1.01 into 10 to the power 5. Area we know that is 50 into 10 minus 4 plus rho GH. Rho is 10, G is 10 into 10 divided by 100 into A2 is 20 into 10 to the minus 4 minus PV. PV is nothing but 204 into area. Pressure divided by area. Force divided by area, that is 204 by A2. A2 is 20 into 10 to the minus 4. Okay. But it's nothing but P naught plus rho GS. So this is the same stuff without area. So 102 into 10 to the 3 will come. So you can solve it and calculate it by yourself, because I have to cover other things also as well. And we are running out of time. The next topic I will be going to discuss is what will be the pressure in the accelerated, variation of pressure in the accelerated fluid. Variation of pressure in accelerated fluid. So case first is vertical acceleration. So we have a fluid in this vessel. Here it's P naught A. There is some pressure at the base. Let's say P. Height of the fluid is H. So now it is, let's say, moving upward with acceleration A. So we need to find what is the pressure at the base if the vessel with a fluid of density rho is accelerated with a with a. Okay. So we need to find out the pressure at the base. So for that, we again need to make the free body diagram, and we need to understand that either use pseudo force method in making the free body diagram. So in the pseudo force method, what we have to do is we will sit here and we will sit here and we will see according to us fluid is at red, and this whole container with me myself is moving in upward direction with acceleration a. So if it is, this is the weight that is acting in this direction. So one thing to note is don't confuse with fluid dynamics. It is still a fluid statics. We can consider fluid dynamics only if fluid is separated from the vessel. But in this case, fluid is not separated, and we are allowed to consider in a pseudo force manner that the fluid is at rest. So it is this topic will also come under the fluid statics. Okay. So let's say so now we have to make the free body diagram. So according to pseudo force method, if we take this parcel, so let's make a free body diagram. So it is P naught A, area is A. This is mg. According to pseudo force method, if it is accelerating in this direction, then if we sit here, you will feel acceleration in opposite direction, that is this direction. So m is also acting in this direction. H. So let's make out a balance. So P naught A plus MA plus mg is equals to, this is the normal reaction, that is PA is equals to PB into AB. So P naught A is the same AB, mass is rho G, sorry, rho A into H into A plus rho AB into H into G is equals to PB into AB. So P naught, so you can cancel out AB from all of it plus rho H into A plus G is equals to PB. So the pressure at the base is this, and we can also write it like P naught plus rho H G effective. So let's say if this moves in opposite direction. If this is if this is accelerating in opposite direction instead of this direction, if it is, let's say I'm taking another pen and going to the solution with that. Let's say if it is moving this direction, then the only change that will happen is MA become minus MA. So for that, if A is in opposite direction, then P naught A minus MA, only the direction of A will change. Mg is equals to PB into AB, and what we get is PB is rho H into G minus A, rho H into G minus A plus P naught. Okay. So that is the variation of pressure in the accelerated fluid in the vertical direction. Let's take a second case. That is horizontal direction. Acceleration in horizontal direction. So if you have this vessel and it is filled with fluid, and now you are accelerating it in this direction. I am making how how the shape of the fluid will change inside the vessel if it is accelerating in this direction. So it will become this. I will prove it why it is coming like this. Okay. So now, because this is moving in horizontal direction with an acceleration A, so why the shape will become like this? That's the question. So that you can interpret by simply thinking that if I made a free body diagram of this, mg is acting normally because it is accelerating in this direction. If you sit using pseudo force method, so you will feel the acceleration in this direction and this will become ma. The resultant force to this fluid, this complete fluid parcel is this. And it has to be noted that in any free surface of liquid, the resultant force acts perpendicular to the surface. Because now the resultant force is like that, so the free surface must be like this, something like this. That should be perpendicular to it. So that's why the shape comes out to be like this. Let's calculate the pressure because now it is accelerating in this direction. So will also be some pressure gradient that came. And let's calculate that due to horizontal acceleration. So now we know the shape by our understanding. So let's take a fluid parcel here. Let's take fluid parcel here. Let's say this is height h. This is, let's call this point to be P1. Area is same A. This is PB. Area is same A. This is height h. Let's call it theta. We need to find theta also. So what happens if it is at rest? If it is like this, then PA into A should be equals to PB into B into A. So PA is equals to PB. That we have seen in previous lecture in non-accelerated fluid. But now the fluid is accelerated in this direction. So there is another additional MA acting at here. So now PV comes out to be PA into A. Sorry. So that's the normal reaction to this. This is also normal reaction to this. So MA plus PB into A is equals to PA into A. So PA minus PB into A comes out to be rho. Let's say this is L, this is H. So rho into H into L, that is mass into acceleration into area. Rho L, sorry. So mass is rho into volume is L. Area of this is A. So rho LA into A. So PA minus PB comes out to be rho LA. Now if someone asks what is theta? So from figure, tan theta can be given as H by L. But if we don't know what is H, so we can calculate H is, so we need to balance it, balance the force in vertical direction. If we want to balance the force in vertical direction, so PA is nothing but P naught plus rho GH and PB is nothing but P naught. So if you put it here, PA minus PB, so rho LA comes out to be P naught rho GH and sorry, we need to find out H. So H comes out to be A by G, AL by G. So tan theta comes out to be AL H by G. So that is, and L is already there. So it comes out to be, which is on A by G. So I will be giving one question for tomorrow and then we'll start tomorrow's lecture with that question. So the question is, a cubical container with side L is completely filled with water. Calculate the horizontal acceleration of the container so that half of the fluid will be will came out of it, will come out of the container. Options are options are 2g by 3, g, g by 2, none. So we'll start tomorrow's class with this question. Okay. Okay. Thank you.